Welcome to Joshua Production, and today we're going to be looking at coordinate geometry. So coordinate geometry is defined as the study of geometry using coordinate system. This is the study of geometry using coordinate system. And from our definition there, we see that we have two terms. We have the study of geometry using coordinate system. So for us to understand geometry, we need to understand coordinate system. And we can understand coordinate system by knowing the Cartesian plane. So let us draw an example of the Cartesian plane. So as you can see, that's our Cartesian plane or our x or y plane. And for us, we can identify this triangle. If we say this is triangle A, B, C, we can find the coordinate of each point. So we can say that point A there, it's on 2, 5. So the first thing that is supposed to do is to give the x coordinate. So the x coordinate of A there, it's 2. Then the y coordinate is 5. So the general formula that you use when finding the coordinate of each point, you give the x coordinate, then you give the y coordinate. Let us identify the coordinate of B. The coordinate of B there, the x coordinate, that's 10, the y coordinate, that's -4. What about C? Let's move to C. C there, the coordinate of C is on the x coordinate of 2. Then what about the y coordinate? It's on which y coordinate? It's on -4. So these are the coordinates of these points, and this is going to take us to our first thing, which is our first subtopic, which is calculating the length of a straight line between 2 points. So calculating the length of a straight line between 2 points. So calculating the length of a straight line between 2 points. And the first thing that I'm going to show you is how we get this formula. So we're going to do the same thing. We're going to start by drawing up our Cartesian plane. And this is our Cartesian plane. If this is y, this is x, and we say that this is our point P, this is our point R, and this is our point Q. And let's take, for instance, we are trying to calculate, we have been given an equation, and the question says calculate the length of line PR. So you are trying to calculate line PR there. And as you can see, this triangle is a 90-degree triangle. That means that that's the hypotenuse. We have the hypotenuse there. So we can calculate the length of this line by adding these two, by adding the squared of these two sides of PQ. We're going to say PQ squared and RQ and RQ squared. So for us to calculate PR there, we can say PR squared is equal to, we're going to use the same concept of Pythagoras theorem. PR squared is equal to PQ squared plus RQ squared. And since the point since the line is starting from point P to point R there, so it means P is our starting point and R is our ending point. So we can say the coordinates of P there can be x1 and y1, since it is starting at point P, and since it is ending at point R there, point R is going to be x2 comma y2, and Q there is going to be on x2 comma y1. Let us go back to the formula. So here we can say PR squared is equal to PQ. For us to find PQ there, we can say our x2 minus our x1. That's going to give us length PQ. So we can put that in brackets. We can say x2 minus x1 squared plus, what about RQ? For us to find RQ there, we're going to consider the y-axis. This is because this is vertical, PQ is horizontal. So for us to find RQ there, we can say our y2 minus our y1. We have our y1 there squared. So for us to find PR, we can say the square root here and the square root this side. So this is going to give us the square root of x2 minus x1 squared plus y2 minus y1 squared. So this is the formula that we use when calculating the length of a straight line between 2 points. So we are going to continue. We're going to continue with finding the length of a straight line between 2 points, and we're going to look at some of the examples. So the first, our example reads, find the length of each of the following lines on the Cartesian plane. So we have A. You're supposed to calculate line AB if A is 9,5 and B is 3,13. So we are going to start with the first question. So the first thing that you're supposed to do there is to identify your x1 and your y1. You also need to identify the x2 and the y2. So that's the first thing that we are going to do. So the line is starting from point A there, then it's going to point B. That means that our coordinates for A, we are going to write them. This is 9,5. And from this means that this is our x1, this is our y1. And that of B, we have 3,13. That means that this is our x2 and that's our y2. And from this we can write the equation. So that's going to be line AB is equal to the square root of x2 minus x1 squared, then plus y2 minus y1 squared. So our AB will be equal to the square root. Our x2, we know that our x2, that's 3. So we're going to say 3 minus our x1, that's 9. Squared plus our y2 is 13. So we're going to say 13 minus our y1, that's 5. So we can simplify the brackets. So 3 minus 9, we are going to have a negative 6 squared plus 13 minus 5, that's 8. So we're going to have 8 squared. So we have that. So we can say AB is equal to negative 6 times negative 6, that's 36, then plus 8 multiplied by 8, that's 64. So our AB will be equal to 36 plus 64, that's 100. And the square root of 100, that's 10. So when you find your final answer, you need to include the units. So the length of line AB is 10 units. So that's how you calculate the length of line AB. Let us now look at question B. At question B, we're supposed to calculate line JK. If J is negative 5,4 and K is negative 2, negative 7. So the first thing that we're going to do is to identify our X1 and our Y1. We also need to identify our X2 and our Y2. So since the line is starting at point J, so those coordinates we have negative 5,4, and this will be X1 and Y1, and those of K, which are negative 2, negative 7, this will be X2 and Y2. So you can finish up answering this question. Just write up the formula and replace these numbers in the formula. So today we're going to proceed with coordinate geometry, and we're going to look at our second subtopic, which is finding the midpoint of two lines. So finding the midpoint of two lines. So the midpoint of a line segment is the point on the line segment that lies exactly halfway between the two endpoints of the line segment. So the midpoint of a line segment is the point on the line segment that lies exactly halfway between the two endpoints of the two lines. And as you can see, I've already drawn my Cartesian plane and have line AB, and line A there, it's having the coordinate of x1, y1. As you can see, we have our x1 there and our y1 there. Then point B is on coordinate x2, y2. As you can see, I have x2 and y2. So the midpoint of line AB can be represented by capital letter M there, and the coordinates of point M have xm, ym. So we can say that xm is halfway between x1 and x1 and x2. So xm is exactly halfway between x1 and x2. So for us to calculate xm there, we're going to say xm is equal to x1 plus x2 divided by 2. Then as to find ym, so ym is halfway between y1 and y2. So ym is equal to y1 plus y2 divided by 2. And for us now to write our general formula, these two formulas that we have written of xm and ym, they are going to help us out. So we're going to say that finding the midpoint will be equal to x1 plus x2 divided by 2, y1 plus y2 divided by 2. And as you can see, this formula is just derived from from xm and ym. So this is my xm and this is my ym. Let us now look at the examples. So example 1 reads, find the coordinates of the midpoint of A 6,3 and 4,5. So my 1A there have coordinates of 6,3 and 4,5. So the first thing that I'm going to do is to write my x1 and my y1. I'm also supposed to indicate my x2 and my y2. After I've done that, I'm going to write down the formula. I know that midpoint is equal to x1 plus x2 divided by 2, comma y1 plus y2 divided by 2 there. So my x1 I know that's 6, so 6 plus my x2, that's 4 divided by 2. My y1 that's 3 there, plus my y2, that's 5 divided by 2. So 6 plus 4, that's 10 divided by 2, comma 3 plus 5, that's 8 divided by 2. And from this I can say 10 divided by 2, that's 5, comma 8 divided by 2, that's 4. So our midpoint there is 5, 4. Let us look at 1b. 1b there we have negative 3, 4 and negative 9, 4. So 1b I have negative 3, 4. I also have negative 9, 4. So the first step is to write down your x1 and your y1. You're also supposed to write your x2 and your y2. So this is my x1, this is my y1, this is my x2, this is my y2. And after that I'm going to write down the formula. Midpoint is equal to x1 plus x2 divided by 2, y1 plus y2 divided by 2. My x1 there is negative 3. Then we have a positive there. What about my x2? My x2 is negative 9. So I'm going to say negative multiplied by positive there. We're going to have negative. So this is going to be negative 9 divided by 2. Then my y1, that's 4, plus my y2, that's 4. So negative 3 minus 9, that's negative 12 divided by 2. Then 4 plus 4, that's 8 divided by 2. And from this I can continue here. So my midpoint will be equal to negative 12 divided by 2, that's negative 6, comma 8 divided by 2, that's 4. So my midpoint there is going to be negative 6, 4. Our example 2 reads, find the coordinates of P if the midpoint of PQ is 2, negative 4 and point Q is 6, negative 8. And from that question we're supposed to understand something. Here we are trying to calculate the coordinates of P. We're trying to calculate the coordinates of P there, and we have been given the midpoint. The midpoint we have been given, which is 2, -4, and we have only been given point Q, which is 6,8. So the first thing that I'm going to do, I'm going to write down the information that I've been given. So this is question 2. I know that PQ, the midpoint of PQ have been given as 2, -4 there. Then I've only been given point Q, which is 6, -8, and I don't know point Q. I don't know point P there. Point P I don't know, so I can say that to be my XP and my YP there. Then I can represent the coordinates of Q. I can say that's going to be my XQ, and that's going to be my YQ. And we know that this point 2 there, 2, we can say 2 represents XM and -4 represents YM. So let us write down the formula. So the formula of calculating XM there, we're going to say XM is equal to, we're going to add XP plus XQ. So we're going to say XP plus XQ divided by 2 there. So we can say XM, we know XM is 2 there, so we can say 2 is equal to 2 is equal to XP. We're trying to calculate XP, which is the coordinate of P there, plus XQ, that's negative, XQ, that's 6, sorry, that's 6 divided by 2 there. Then from this we can say divide by 1 there, we cross multiply there, so we can say that's going to be our XP. If we multiply 1 and XP plus 6, we're going to say XP plus 6 is equal to 2 multiplied by 2, that's 4. So we come this side, so we can collect the like terms there. You can say XP is equal to 4. When 6 goes to the other side of the equation, it's going to be -6. So XP there is equal to 4 minus 6, that's -2. So the coordinate of X there, the coordinate of X for P is -2. Let us find the coordinate of Y for P. So we are going to do the same thing. We are going to say Y, we are going to say YM there is equal to YP plus our YQ divided by 2. So that's going to be our formula, and from that we can replace. So we know that our YM is -4. We know that that's -4. -4 is equals to we are trying to calculate the coordinate of P, which is the y coordinate. What about the coordinate of Q? So yq, we know that's -8. So negative multiplied by positive, we're going to have negative here, so this is going to be -8 divided by 2 there, so we're going to say over 1 there. Then we can say, we can close multiply there. Then we're going to have 1 open bracket yp minus 8 there is equal to -4 multiplied by 2, we're going to have -8. And to open up the brackets there, we're going to multiply 1 with everything inside. So 1 multiplied by yp, we're going to have yp minus 1 multiplied by 8, we're going to have 8 is equal to -8. And from that we can collect the like terms. We can say yp is equal to -8 plus, when -8 goes to the other side, it will be positive there, so plus 8. So yp is equal to 0. So we can say the coordinates of P there. So the coordinates of P, for x we calculated, what was for x? So for x we calculated as -2 there, as you can see, so that's -2. So we can say the coordinates of P, it's -2, 0 there. So that's the coordinates of P. So that's going to be your answer. Let us now look at the gradient intercept form. Let us now look at the gradient intercept form. And the standard form of the equation of the straight line is given as y is equal to mx plus c. So where m is the gradient and c is the y intercept. So where m is the gradient and c is the y intercept. So the y intercept is the y coordinate at the point where the line cuts the y axis. So the y intercept is a point where the line cuts the y axis. So we can also say that the x intercept is the x coordinate at the point where the line cuts the x axis. So we have said that the standard form of the equation of the straight line is given as y is equal to mx plus c. And from this equation, what we know that our m there represents the gradient. So that's the gradient. And our c there represents the y intercept. We have said that our y intercept is the y coordinate at the point where the line cuts the y axis. So m represents the gradient and c represents the y intercept. And from the Cartesian plane, let me show you the y intercept. So for example, this is our Cartesian plane. We have our y, we have our x there, and we have these points. If this is point A and this is point B, and point A there, we say that this is 0, 2, and point B there, if this is 2, 0 there. So we can say our y intercept there, it's 2, because this is the y coordinate where the line cuts the y axis. So that's 2. So you can say your c there, which is your y intercept, it's 2 there. Then what about your x-intercept. So your x-intercept is the x coordinate where the line cuts the x-axis. So our x-intercept there, we can say our x-intercept is equal to 2. And for the equation of the straight line, as long as you have your gradient and your y-intercept, that means that your equation of the straight line will be known. So for example, if the question says your gradient is given as 2 and if your y-intercept is given as 2, you can say that your equation of your straight line will be equal to, so y is equal to 2x, since the gradient is 2, so we are going to replace m with 2, so that's going to be 2x plus c there. C, we know that's the y-intercept, and we've been given as the y-intercept, sorry, this must be c. I've been given that our y-intercept is 2 there. So this will be your equation of straight line. Another example that I'm going to give you, if you have been given the gradient is equal to half and the y-intercept you have been given as 5, and you have been told to find the equation of this straight line given this information. So we're going to say y is equal to mx plus c. So y will be equal to, we know that the gradient, that's half, so we can say 1 over 2x plus c there, that's 5. Let us now look at the examples. So example 1 reads, find the gradient of the straight line a there with a gradient of 2 and y-intercept of 5. So our 1a there, we have been told that the gradient is 2 and the y-intercept we have been given as 5. So we're going to write the general form of writing the straight line. So y is equal to mx plus c there. So our y will be equal to m, we know that's 2, so it's going to be 2x plus c there, we know that's 5. So that's going to be our answer. What about b? B, we have been told that the gradient is equal to negative 5 over 4 and our y-intercept we have been given as 0. And from this we're going to say y is equal to mx plus c. So we know that m there, that's negative 5 over 4 x plus, and our c we have been given as 0. So that from that we can say y is equal to negative 5 over 4 x. So we're not going to write this 0, we're going to just write our negative 5 over negative 5 divided by 4 x. So that's going to be our answer. What about c? C reads, with a gradient of 7 over 8 and a y-intercept of negative 3. So c with a gradient of 7 over 8 and a y-intercept of 3. So c is equal to y-intercept of negative 3. So we're going to say y is equal to mx plus c there. Then we're going to say y is equal to m, we know that is 7 divided by 8 x, then plus our c is negative 3, so negative 3 there. then we're going to say y is equal to 7 divided by 8x positive multiplied by negative. We're going to have negative 3 there. So our equation of the straight line is going to be y is equal to 7 over 8x minus 3. Let us now look at example 2, and our example 2 reads: find the equation of the straight line A with a gradient of 2 and an x-intercept of 4. So the gradient we have been given as 2 and our x-intercept we have been given as 4 there. And let us take note that all these are x-intercept, so there was a mistake with the equation. So this is also the x-intercept. So question 2a, I've been told that the gradient is 2, isn't it? I've been told that that's 2, and the x-intercept I've been told that that's 4, and we know that the x-intercept is the x-coordinate where the line cuts the x-axis. So we can say that our coordinates there of x-intercept, we're going to have 4, 0 there, since the line is cutting since the x-intercept is the x-coordinate, which is this, where the line cuts the x axis. So we know that that's our x and that's our y. And since we have this information, we can say y is equal to mx plus c there. And from this we can calculate our y-intercept. Since we don't know our y-intercept there, we can calculate our y-intercept. So since we know our x and our y, we can replace that in the formula. So we can say y there, y we know that's 0, so 0 is equal to m that's 2, open bracket. We know that our x that's 4 plus c. So we're going to have 0 is equal to 2 multiplied by 4, that's 8, plus c there, and we can move 8 to the other side of the equation, so that's going to be negative 8 is equal to c. And since we know our y-intercept, which is c, we can say that our equation of the straight line will be equal to mx plus c there. So y is equal to, we know that the gradient is 2, so that's going to be 2x. What about the y-intercept, which is c? We know that's negative 8. So we're going to have y is equal to 2x minus 8. So that's going to be the equation of the straight line of question A. So you can say we have 5, 0 there. So we can say y is equal to mx plus c. So we are going to calculate c there, since we don't know c, but we have our x and our y. So our y there, that's 0, as you can see, is equal to m there, that's negative 3 divided by 5, and our x there, we know that's 5, plus c there. So to simplify this equation, you can say 5 there 1, 5 there 1. So we're going to have 0 is equal to negative 3 plus c there, and when negative 3 goes to the other side of the equation, it's going to be 3 is equal to c. So we know that our y-intercept, that's 3, and we're going to say our equation of the straight line will be equal to mx plus c. So y is equal to, we know that our gradient is negative 3 over 5, so negative 3 over 5x plus our y-intercept, we know that's 3. Let us look at question 2c. So with a gradient of 7 over 8 and a x-intercept of negative 3. So that's our C. So the gradient we have been given as 7 over 8, and we have been told that our x-intercept is negative 3. Let me just check that. Yeah, negative 3 there. So that means that's going to be negative 3 divided by 0. So we know that's our x and that's our y. So m is equal to mx plus c. We know that our y, that's 0. So 0 is equal to our gradient there, that's 7 over 8. 7 over 8 there. 7 over 8. With a gradient of, let me just check the equation. Sorry, there the question is supposed to be, there was a mistake with this question. The question there, it's supposed to be 4 over 7. 4 over 7 there. Then we have negative 9. So this is negative 9. I'm sorry about that. I think when preparing the questions there was just a mistake. So we need to change that. We know that this is 4 over 7 and this is negative 9. Negative 9 there. So we're going to calculate C there. We're going to say 0 is equal to m there. We know that m is 4 over 7 and our x, we know that's negative 9. Negative 9, then plus c. So we're going to say 0 is equal to 4 multiplied by negative 9, that's going to be negative 36 divided by 7, then plus c there, and our negative 36 over 7 is going to go to the other side of the equation, and we're going to have 36 divided by 7 is equal to c. So our y-intercept, we know that that's 36 divided by 7. So we're going to say y is equal to mx plus c. So y is equal to our gradient, we know that's 4 over 7. So 4 over 7 plus 4 over 7x, then plus c we have calculated as 36 over 7 there. So that's going to be our answer. Let us now look at the double intercept form. So the double intercept form is a form where you're going to be given the x-intercept and the y-intercept. So you're going to be given the x-intercept and the y-intercept, and from that information that you're going to be given, you can calculate gradient. And after calculating gradient, you can write the equation of the straight line. So I've said that the double intercept form is a form where you're going to be given the x-intercept. You're also going to be given the y-intercept, and from these two information you can calculate your gradient. And after you know your gradient, and since you know your y-intercept, which is c, you can write the equation of the straight line, which is equal to mx plus c. So for the x-intercept, this is going to be in this form. It will be x comma 0, so you're going to have a value there. And for your y-intercept there, we're going to have 0 comma y, so our y is going to be known. And if we've been given these two informations there, we can calculate our gradient. So gradient is given by this formula: y2 minus y1 divided by x2 minus x1. So after you calculate your gradient, you're going to write down the equation of the straight line. As simple as that. Let us now look at the example that we have been given. So the example reads: find the equation of a straight line A with an x-intercept of 3 and a y-intercept of 6. So A, we have been told that our x-intercept of 3 there and a y-intercept of 6. So I'm going to show you two ways on how you can calculate this equation. So we are going to have method 1, and from our method 1 we know that our x-intercept is 3, so that's going to be 3 comma 0 there. Then our y-intercept, we know that that's going to be 0 comma 6, and since we have that information, we can calculate the gradient. So we can say y is equal to mx plus c there. So we know that this is our x and this is our y. This is also our x and this is our y. This is x1, this is y1 there, this is x2, this is y2. So y there, I can say that's going to be 0 there. So I'll say 0 is equal to, we are trying to calculate gradient, so we're going to say we don't know our gradient. What about our x? We know our x, that's 3, plus we know our y-intercept, that's 6. So we're going to say 6 can go to the other side of the equation, so it's going to be negative 6 is equal to 3m. So to find gradient, we're going to say over m, or over 3 over 3. So 3 and 3 will cancel out. Negative 6 divided by 3, that's negative 2, is equal to m. So we know our gradient there, that gradient is negative 2, and we know our y-intercept. Our y-intercept have been given in the question as 6. So we can say y is equal to mx plus c. So y is equal to negative 2x plus 6. So that's going to be the equation of the straight line. So this is method 1. Let us look at method 2. Let us look at method 2. So the first thing that we're going to do, we're going to write down our x-intercept and our y-intercept. So we know that's 3, 0 as our x-intercept, and our y-intercept, that's going to be in this form. So we know this is x1, this is y1, this is x2, this is y2. And from this we can calculate the gradient. But gradient, we're not going to use the equation which is in the standard form, but we're going to use the formula of finding gradient. So we know that gradient can be calculated as y2 minus y1 divided by x2 minus x1. So our gradient there, sorry, that's supposed to be m. That's supposed to be m. So our m there, which is gradient, our y2, we know our y2, that's 6. So 6 minus our y1, that's 0. Our x2 there, our x2, that's 0, minus our x1, that's 3. So gradient is equal to 6 minus 0, that's 6, divided by 0 minus 3, that's going to be negative 3. So we know that our gradient there is going to be equal to 6 divided by negative 3, that's going to be negative 2. And since we know that our y-intercept is 6, we are given in the question as the y-intercept, which is 6. So we can say y is equal to mx plus c. So y is equal to, we know that our gradient is negative 2 there, so we're going to say negative 2x plus our y-intercept, we know that's 6. So that's going to be our answer. And as you can see, this answer and this answer is the same. So you can choose the method which is very simple to you. Let us look at question B. Question B reads, with an x-intercept of negative 12.5 and a y-intercept of 5. Negative 12.5 and a y-intercept of 5. So our y-intercept, which is c, we know that's 5, and from that we can write down the two coordinates. We can say negative 12.5 divided by 0. We can also say 0, 5. And to find this question, you can also use two methods, but I'm just going to use one method. You yourself make sure you do the other method, which is method 2, and compare the two answers. So I can say that y is equal to mx plus c there. Then I know this is my x1, this is my y1, this is my x2, this is my y2 there. So y, we can say y is going to be equal to 0. So y is 0 there. M, we are trying to calculate m. Then we know that x is negative 12.5, negative 12.5 plus c, we know that our y-intercept, that's 5. Then we can transfer 5 to the other side of the equation, so it's going to be negative 5 is equal to a multiplied by negative 12.5 is going to be negative 12.5 m. So we can say divide by negative 12.5 divide by negative 12.5, and from this is going to cancel out. We're going to have 5 divided by 12.5 is equal to m there, and from that we can simplify this. We can say 2.5 there is going to be 2, and 2.5 there is going to be 5. So we can say our m, which is gradient, will be 2 over 5. 2 over 5 there. So we can write down the equation of the straight line. So y is equal to, we know that our gradient we have calculated as 2 divided by 5 x plus, and the y-intercept we are given in the question as 5. So this is method 1. Make sure you also use that method 2 and compare the two answers. Let us now look at parallel and perpendicular lines. So if two straight lines are parallel, then their gradient is the same. So if m1 and m2 are the gradients of two parallel lines, then we can say m1 is equal to m2. If two straight lines are perpendicular to each other, this means that the product of their gradient is negative 1. So if we have m1 and m2 as the gradient of the two perpendicular lines, then m1 multiplied by m2, that's going to be equal to negative 1. So I've said that for the parallel lines, if we have been given the gradient of two parallel lines as m1, we also have m2 as the gradient of two parallel lines. So we know that the gradient of two parallel lines is the same, so m1 is going to be equal to m2. Let us look at for two perpendicular lines. So for two perpendicular lines, so if we have these two gradient as m1 and m2, and we know that the products of two perpendicular lines, we know that the products of the gradients of two perpendicular lines is equal to negative 1. So this means that m1 multiplied by m2, that must be equal to negative 1. So that's the principle on parallel lines and perpendicular lines. Let us look at some of the examples. So example 1 reads, Find the gradient of a straight line that is A, parallel, and B, perpendicular to the lines given by each of the following equations. So Roman numeral 1, I have y is equal to x plus 3 there. So for A, I'm supposed to calculate the gradient of the line which is parallel to this line, and for B, I'm supposed to calculate the gradient of the line which is perpendicular to this line. So I'll say A there. Since I know that the equation is y is equal to x plus 3, and we know that the gradient is the coefficient of x there, and the coefficient of x there, we have an invisible 1. So the gradient of that equation is 1. So for our perpendicular line, the gradient of our perpendicular line there is going to be 1. So that's going to be our gradient of our perpendicular line there, be equal to 1. So let us look at B. We are supposed to calculate the gradient of the parallel of the perpendicular line, which is to that. We have calculated that the gradient of the parallel line will be 1 there. What about for a perpendicular line? So y is equal to x plus 3, and since there we have an invisible 1, which means our gradient 1 there, we can say that's going to be 1. So we can just represent this as m1 and m2 to just differentiate those. So our m1 is going to be equal to 1 there. So to calculate the gradient of a perpendicular line to this line, we're going to say m1 multiplied by m2 of that of a perpendicular line must be equal to -1. So m1, that's 1 multiplied by m2 is going to be equal to -1. So we're going to have m2 will be equal to -1. So our m2, our gradient 2 of this line will be equal to -1. That will be of a perpendicular line. Let us look at Roman numeral 2. So y is equal to negative, what's the equation there? -3/7x. So to find the gradient of the parallel line, we know that there our gradient is -3/7. So our m2 will be equal to -3/7 since parallel lines have the same gradient. What about B, of that of a perpendicular line? And since we know that our gradient 1 of this equation is -3/7, what about that of m2, which is that of a perpendicular line? We don't know, but we know that the product of m1 and that of m2 must give you -1. And since we have our gradient 1 there, which is -3/7 multiplied by m2 is equal to -1, that means we can calculate gradient 2. So that's going to be -3/7. m2 is equal to -1. We can transfer this side. We can just continue this side. So for us to find the value of m2 there, we're going to multiply both sides of the equation by going to say negative 7 over 3 multiplied by negative 3 over 7. M2 is equal to negative 1. So we're going to multiply negative 7 over 3 on both sides of the equation. So multiplied by negative 3 over 7. And as you can see here, this and this is going to go, and this is going to go. So we're going to have our M2 is equal to, sorry, this is negative 7 over 3. This is supposed to be 3. So here we're going to have 7 over 3. So our gradient 2 of the perpendicular line is going to be 7 over 3. Let us look at Roman numeral 3 there, and for Roman numeral 3 we have 2x plus 5y is equal to 10. So we have 2x plus 5y. (2x plus 5y is equal to 10. Let me just compare that equation. Okay, it is correct. So A, we are supposed to calculate the gradient of the parallel line. So as you can see, this equation is not in our standard form. The standard form must be in this form, which is y is equal to mx plus c. So we're going to write down this equation in this form. So we're going to say 2x plus 5y is equal to 10 there, and we can transfer 2x to the other side of the equation. So we're going to have 5y is equal to negative 2x plus 10, and there to calculate y, you can divide by 5, divide by 5, divide by 5. So y is equal to negative 2 over 5x plus 10 divided by 5, that's 2. And since we know now that the gradient of this equation is our m1 is negative 2 over 5, so that means the gradient of the parallel line that is to this line, our m2 will be equal to negative 2 over 5. As simple as that. Let us now look at B, finding the gradient of a perpendicular line. So we know that our gradient, our m1, is equal to negative 2 over 5, and we know that our m1 multiplied by our m2 of that of a perpendicular line is supposed to be equal to negative 1. So our m1, we know that's negative 2 over 5, so multiplied by m2 will be equal to negative 1. So we're going to have negative 2 over 5 m2 is equal to negative 1, and to find m2 there, we're going to say multiplied by the reciprocal of that. We're going to have 5, the opposite of that, we're going to have negative 5 over 2, and this side we're going to have negative 5 over 2. You can cancel out there, so our m2 will be equal to negative 1 multiplied by negative 5, that's going to be 5, then 1 multiplied by 2, we're going to have 2. So the gradient of a perpendicular line is going to be 5 over 2. Let us look at Roman numeral 4. So I have 6x minus 2y plus 7. 6x minus 2y plus 7. we have 6x minus 2y plus 7 is equal to 0. And as you can see, this equation is not in our standard form, which is given as y is equal to mx plus c. So the first thing that we're supposed to do is to change this equation in the standard form. So for us to do that, we're going to say, so that's going to be our a for calculating the gradient of a parallel line. So 6x minus 2y plus 7 is equal to 0, and we are going to transfer 6x and 7 to the other side of the equation. So we're going to have negative 2y is equal to, when 6x goes to the other side of the equation, it's going to be negative 6x. Then when positive 7 goes to the other side of the equation, it's going to be negative 7 there. And from that, we can say divide by negative 2, divide by negative 2, divide by negative 2. So y is equal to negative 6 divided by negative 2. That's going to be 3x. Then negative divided by negative, we're going to have positive 7 divided by 2. So that means the gradient there, our gradient 1, is equal to 3. That means that the gradient of a parallel line, which is m2, will be equal to 3. Let us now look at B, finding the gradient of a perpendicular line to this equation. So we know that our m1, that's 3, but we don't know our m2. But we know that our general form, we have m1 multiplied by m2 is equal to negative 1. m1, we know that's 3 multiplied by m2 is equal to negative 1. So we can say 3m2 is equal to negative 1. Finding our m2 there, we can say divide by 3, divide by 3. So our gradient 2 there is going to be negative 1 over 3. So that will be the gradient of the perpendicular line. Let us now look at example 2. Example 2a reads, find the equation of the straight line that passes through the point 4, 6 and is parallel to the line y is equal to 3x minus 8. So I've been told that we're supposed to find the equation of the straight line that passes through the point 4, 6. So this parallel line passes through 4 over 6, and it is parallel to this line, which is 3x minus 8. So our first thing that we are supposed to do, we are supposed to identify the gradient. So we know that the gradient of this equation, m is equal to 3. That means that it's going to be equal to this line, the line that we're supposed to calculate. So we can say y is equal to mx plus c, and we know that this is our x and this is our y, and we know that two parallel lines, their gradient is the same. That means the gradient of this line is also going to be 3. So we can say our y there, our y is 6, is equal to the gradient, we know that's 3, our x we know that's 4, plus c. So we can say 6 is equal to 3 multiplied by 4, that's 12, plus c there. and we can say 6. When 12 goes to the other side of the equation, we can say minus 12 is equal to C. 6 minus 12, that's negative 6, is equal to C. And since we know our y-intercept as negative 6, and we know that our gradient is 3, so we can say y is equal to mx plus c. So y is equal to, we know that the gradient is 3, so 3x, then we're going to have plus our y-intercept, we know that's negative 6, so y is equal to 3x minus 6. Since when we multiply positive and negative, we're going to have negative, so our equation of the straight line will be y is equals to 3x minus 6. So that's our first answer there of A. What about B? So B, we've been told find the equation of the straight line that is perpendicular to the line 3x minus 2, y is equal to 4, and passes through the point negative 9, 5. So that is perpendicular to 3x minus 2y is equals to 4. So 3x 3, let me just check that, 3x, no, 3y, sorry, three x minus 2y is equal to 4, and passes through the points negative 9, 5, 5 there. So the first thing that we are supposed to do, we are supposed to find the gradient of this, and after finding the gradient of this, we are supposed to find the gradient of the line that is passing through negative 9, 5. So for us to calculate the gradient there, we're supposed to change this equation in the standard form. So we can say negative 2y is equal to negative 3x plus 4. And to find y there, we can say divide by negative 2, divide by negative 2, divide by negative 2. So y is equal to 3 over 2x minus 2. So you know that our gradient there is 3 divided by 2. And to find the gradient of the line that is passing through negative 9, 5, we know that these two lines are perpendicular to each other. That means that m1 multiplied by m2 multiplied by m2 that is going to be equal to negative 1. So our m1, we know that's 3 divided by 2 multiplied by m2, so that's going to be m2 is equal to negative 1. And from that we can say, to calculate m2 there, we're going to say multiplied by 2 over 3 multiplied by 2 over 3. So our m2 will be equal to, can cancel out, it will be equal to negative 2 over 3. And since we know our gradient there, we can calculate c. So we know that our x, that's our y, So our y there, our y, that's 5, is equal to our gradient there, it's negative 2 over 3, and our x we know that's negative 9 plus c. So we're trying to calculate c there. So to simplify that we can say 3 here, 1, 3 here, we're going to have 3. So we can say 5 is equal to negative 2 multiplied by negative 3, that's going to be 6, plus c there. So we're going to have 5, when 6 goes to the other side, it's going to be negative 6 is equal to c. So we can say that our c there will be equal to 5 minus 6, that's negative 1. So let us just erase something here. So that you can write down our final answer. So since we know the y-intercept there, so we can say y is equal to mx plus 6 there. So y is equal to our gradient. We calculated our gradient as negative 2 divided by 3. So you can say negative 2 over 3x, and we have calculated our y-intercept as negative 1. So that's negative 1. So that's going to be the equation of the straight line that is passing through negative 9, 5.